Hi, this is Leanna from period 5, and here we have our graph of the force that's exerted on a spring. This is one of the smaller springs in our lab, and on the x-axis we have the amount that the spring was stretched. And we said in class that Hookean means that the force exerted on the spring and the change in x, in other words, the displacement of the spring, have a linear relationship. And, well, you can see it's a line. So for our slope, before I continue, let's just note that I accidentally put the units in centimeters and I did not convert my units into meters as I should have done before I graphed the data. So my bad. See, oh no. Anyway, continuing. Based on our slope of 0.04187, well, okay, let's just pretend I converted that. And let's pretend I got 4.187 newtons for every meter as a slope. So to interpret that, it's right here. For every meter that the spring is stretched, about that many newtons of force are exerted on the spring. And here's our equation for the force that's exerted on the spring and the force that the spring exerts on T. I'm not sure. Okay, continuing. Here, this number should actually be 0, is what I thought at first. But then, Mr. Day, you said something about a loading force. Let's see, where did I put that note? Okay. When the stretch is 0 meters, so when the displacement is 0 meters, the loading force is our y-intercept. And my question is, can forces be negative? I don't know. That's why I asked. I will ask tomorrow, maybe. And now we continue the force of the spring. We can generalize it into this formula. K, I believe that's our constant. Yes, K is our constant. It's our spring constant. So for every spring that we use, there's going to be a different number, a different amount of newtons that is exerted for every single meter of displacement of the spring. So now we connected what we graphed to energy, because what we graphed only had to do with force and displacement, and to connect it with our unit, which is storing energy, we figured we had to find the area of our graph, and the area under the graph is nothing but the energy stored in the spring. Amazing. And so we have the equation for the triangle, and we just multiply our variables. And we also learned today that the joule is a unit of measuring energy, and it's newtons times meters. And I suppose we would see that here in our equation. The force is in newtons and the displacement is in meters. And something I noted is that energy doesn't always need to be stored in a spring, because we were just working with springs today, but this equation could apply to anything. Anyway, thanks for watching.